Today we'll be covering our transformation and construction questions, right? We will do more of the transformations. We will just sketch through the construction questions, right? So our first question is, the diagram below shows a triangle PQR. State the coordinates of R, so you all can feel free to
0, 3.
answer. So 0, 3. All agree?
Yes, miss.
So 0, 3, and we write that in the form R, comma 0. Sorry, R open bracket 0, 3. All right, so that's one mark. On the diagram above, draw triangle P prime, Q prime, R prime, a reflection of triangle PQR in the line y is equal to 1. What's the first thing we need to identify?
Miss, do y is equal to 1 line?
All right, where is that line?
Miss, a horizontal line cutting through the y-axis at 1.
All right. So we have here, y is equal to 1. So we are going to reflect in that line. So which quadrants will our image be in?
Two.
Second quadrant?
Let's see, fourth quadrant.
The fourth quadrant, because this is the mirror line. The shape is here, so it's going to be mirrored down here. So where would we put P prime?
Miss,
2, negative 2.
Huh? What's that?
2, negative 2.
2, negative 2. Down here. Would it be so far? So this is the mirror line here.
no, miss. Miss,
This is the mirror
would it
line.
be 2, 0?
So yeah, it will be. So we use our mirror line and we could actually count how many blocks it is away from the mirror line. So P prime is 1 block away. P is 1 block away, so P prime will be 1 block away as well. So P prime will be here. So P prime is actually 2, 0. Any questions to that? So 1 block away from the mirror line, 1 block away from the mirror line. So where would Q prime be? We do the same thing and we count 1, 2, 3, 4. So 1, 2, 3, 4. So Q prime will be 2, negative 3. Nice, yeah. And what about R prime? We go to the mirror line, 1, 2, 1, 2, which is
0, negative 1.
0, negative 1. 1, 2, 1, 2, 0, negative 1. Yes, everyone?
Yeah.
Any questions?
No, miss.
All right, so that's our 2 marks there. Now we're going to, now they said P double prime, Q double prime, R double prime is a reflection of the triangle P prime, Q prime, R prime in the x is equal to 0 line. Where's the x is equal to 0 line?
It's the y-axis.
The y-axis. Correct, because x is equal to 0 at this line. So we put another mirror line. Let's put it in a different color. So we have another mirror line now. And let's reflect. So this is P prime, Q prime, R prime. So reflecting in this line here. What will be the coordinates?
I have -2, 0 for P double prime.
So P double prime, -2, 0. All right, nice. Here, P double prime.
Miss Q double prime is -2, -3.
-2, -3. Yes, nice. And R double prime, someone else? We have so many of you all on. Let's participate. What's R double prime?
That's 0, -2.
0, -2, so it does not change. Do we have any questions here?
No, miss.
All right, so we understand that a reflection preserves distance away from the mirror line, right? So if we see that the mirror line is on the point, so of course 2 points will be touching the same place. It's going to be exactly the same amount of distance on the other side of the mirror line for the image that it is for the object. So all right, we got that done. Are we all clear here for this question?
Yes, miss.
All right.
Miss you R prime is 0, -1, and for R double prime is 0, -2.
Hold on. Let me see how. So for R prime is 0, -2. Where's R? R prime is here, right? So it's 0, -1, -2, -3, -4. So 0, -2. Yeah. Everyone is okay with that? How come y'all didn't
Yes, ma'am.
pick up? This was incorrect. So everybody had -1?
Oh, yeah, Miss I -1. Because it's
Miss, I
2.
have -1.
So remember R prime is here, right? Yeah?
Yeah.
Hold on now. Let's see, this is the mirror line. So P prime here. Q prime is 1, 2, 3, 4. So 1, 1, 2, 3, 4. R prime is up here then. R prime, 1, 2, 1, 3. 1, 2. So it's going to be 1, 1, 2. So R prime will be here.
Yes, miss.
Yeah. So R prime is there. So R prime is 0, -1. And so it will be here as well. So it's also going to be 0, -1. All right, nice. Thank you all. That's what we're talking about. Any questions? Any questions with this part that just happened here? So remember, we have a mirror line. This was the mirror line here. So the distance from the mirror line on both sides are the same. So if it's 1 block away, this will be 1 block away. If it's 1, 2, 3, 4 blocks away, it's going to be 1, 2, 3, 4 blocks away. If it's 1, 2 blocks away, it's going to be 1, 2 blocks away from the mirror line. I know it could be confusing thinking about the axis doing it on the axis and not on the line itself, the mirror line itself, the line that they told us y is equal to 1. All right, so we're good there, right? So let's go. Describe fully the single transformation that maps P double prime, Q double prime, R double prime onto PQR. All right, so we go back up and well, sorry. We had it here. Right, so this is P prime, Q prime, R double prime, P double prime, Q double prime. What maps P prime, Q prime, R prime onto so what maps the double prime onto the triangle itself? So what maps this onto this?
Miss, a rotation.
So a rotation. Why do we think it's a rotation?
Miss, well, I thought it was a rotation because if you like draw another triangle in quadrant 2, and then it would be like, Miss, if you rotate like a triangle and you like try to draw it, like if the triangle is rotating, it ends up right back to the object, like how the object is positioned.
Mm-hmm. Okay, so we see, we start to eliminate stuff. We see that it's not a translation, it's in opposite directions. We see that it's not an enlargement per se, because the scale factor remains the same, right? We see that it is not a reflection, right? But we are seeing that the shape is in a different angle. So we are thinking it's a rotation now. So when we deal with rotation, what are the key things we need to find out to be able to describe the rotation? What are we going to identify?
Direction of the turn.
So the direction. What else?
Miss, the center of rotation.
The center of rotation, and what else?
The degree.
The degrees. So let's go. How do we go find? So the first thing we want to go find is our center of rotation. How do we go about doing that?
Miss, rejoin the corresponding vertices.
So we're joining the corresponding lines. So this is R to R, R double prime to R. Let me use something bigger. R to R double prime. Then we're going to connect P to P double prime, and then we're going to connect Q to Q double prime using your rulers. Did we identify a center of rotation?
Yes, Miss.
At what point?
Miss 0, 1.
0, 1. Any questions here? No questions? All right, so we have our center rotation. Now, what direction would we go in? So we're going from here to here.
Clockwise.
Clockwise. And what is the measure of our rotation?
90 degrees.
90
270.
270 to go from here to here. Here to here.
180.
180 degrees. So remember, we take our protractor and we measure this, right? So we can go from P double prime to P right here, and it's a measure of 180 degrees. So how would we write this up? Now that we have all three, so it was clockwise. Sorry, we have clockwise already, 180 degrees. So how are we writing this? So we are going to put a rotation about the point 0, 1, 180 degrees clockwise. You can say triangle P double prime, Q double prime, R double prime. R double prime was mapped onto P prime, Q prime, R prime by a rotation about the point 0, 1, 180 degrees clockwise. Do we have any questions here? If it was 90 degrees more, it would have been in this quadrant, right?
No, so what have been negative. 3 degrees is one negative 180 is just 180.
So negative 180 clockwise. Yeah, so we could write that as well. You all remember? All right, so the triangle PQR undergoes an enlargement of scalar factor 2 now. Calculate the area of its image. So how do we work out the area of an enlargement?
Miss K is equal to area of the image over area of the object.
Yes, but they gave us K. We have to work out the area of the image.
K by the power 2 multiplied by the area of the object.
K squared. By the area of the object. Yeah? Don't forget the square. So right, so what is K?
2.
2.
K is 2, so 2 squared by what's the area of the object?
3.
The area of PQR. What's the area of PQR? Base by height over 2. What's the base of PQR?
3.
1, 2, 3. By what's the height?
2.
So this is the base here. 1, 2, 3. The height is 1, 2, all over 2. So 3. All right, so 2 squared by 3, giving us
12 centimeters. It's 12 units squared.
so 4 by 3, 12 units. Or we can put centimeters, right? Because we know that each block is a centimeter. Yeah. 12 centimeters squared. Do we have any questions with us?
No, miss.
Right, so base, be able to, don't be afraid to twist your head a little bit, turn the paper around a little bit in order for you to see what you have to see, right? So this is the base and this is the height. If you turn it around, you'll see that this is the base, this is the height. All right. So we have 12 centimeters squared. Next one. Everybody did this, got through with it?
Yes, miss.
Right, so we know that always draw your sketch first. So this you will know if you're correct, right? Because you have to measure it back. So you have your sketch. First of all, you're drawing a long line. You create a point called A. You open your compass and you measure 5 centimeters. Create an arc called here B, right? 5 centimeters. Then you're going to create a 90 degrees at ABC. So my sketch will be AB, 90 degrees at ABC. So I know here is going to be C, which is 90 degrees, and I have to connect here. This is my sketch, right? I always start with a sketch so I know what I'm doing. So I'm going to create a semicircle here, open my compass, create an arc, put it on this, create an arc, connect it at B, forming my 90 degrees, and then creating my 60 degrees by cutting, opening my compass and cutting on whatever side I want the angle, taking the point here now, cutting this and then connecting it until the 2 lines meet. So I'll end up at 60 degrees and 90 degrees and ABC, showing all these lines to get your full working. We're good, right?
Miss, I get your shape here, but I just flip it like I put BA in a AB.
So yours was like this?
Yeah, miss.
Yeah, that's fine, that's fine. Yeah, once you
Okay.
have your stuff as A, B, C, yeah?
Yeah.
All right, nice. So now, okay, easy stuff. How many faces?
8.
8. How many edges?
12.
So the faces are the actual flat surfaces, right? So 1, 2, and then 6 going around. So 6 plus 2 is 8. How many edges?
18.
I heard a 12 just now. What's an edge? So these lines, right?
Yes, miss.
So we have 6, 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3, 4, 5, 6. Right? And then we have 1, 2, 3, 4, 5, 6. So 6 by 3, we have 18 edges. And how many vertices? Vertices are the little corner parts now. How many? So we have 6 and 6. Somebody mix up the 12 and the 18. The 12 and the 18. Any questions here?
No, miss.
All right. So part C, we have a quadrilateral. We already watching the image. We already know what it is, right? A quadrilateral PQRS and its image P prime, Q prime, R prime, S prime are shown on the grid below. Write down the mathematical name for PQRS. What is that?
A trapezium.
All right, nice. All is well. A trapezium, everybody, right?
Yeah, miss.
Mhm.
Yes, miss.
PQRS is mapped onto P prime, Q prime, R prime, S prime by an enlargement with scale factor K about a center AB. Using the diagram above, calculate these things. So we now need to go, we have the object, we have the image, and we need to find for C, AB, which is the center of enlargement, and K, which is the scale factor. So which one is the easiest? We can find K. K is just choose corresponding sides and do what?
Divide.
So I'll choose P prime S prime over PS. And how much is that? How much is P prime S prime?
Miss 6,
6 over how much is PS?
2.
2. So we get 3. I could just try her line just to make sure. I'll take Q prime, P prime over QP. How much is Q prime, P prime? We're counting the centimeters, right? The blocks. How much is that?
3.
3 over.
1.
So we know our scale factor is 3, right? So K is 3. How do we find our center now of enlargement? What do we do?
Miss, join corresponding lines.
Join the corresponding lines. So that's going to give me R prime Q prime S and PP prime. So now that we join them and nothing happened, what happened? So what do we do when we join them? And okay, it's nothing. No intersection, no common points. What do we have to do here? Huh?
Miss, find the line they all pass through.
So we have to extend all the lines. Yeah. So we know
That's
that an enlargement could be on the same side or on opposite sides. So we are seeing that this is on the same side. So all we're going to do is extend our lines until they meet at one common point. So what's our center of rotation from extending our lines?
-4, 1.
-4, 1, correct? Anyone has any questions to ask? This is where they intersect. So you see something like looking like that for your center of enlargement. Extend your lines. Extend your lines. And look for that common point. All right, so C is -4, 1, K is 3. So we out of here. All right, so we have, so anyone attempted this?
Yes, miss.
All right, nice. Anyone else? So we have a transformation M. So these are 2x2 transformation matrix, right? Maps R onto R prime as shown in the diagram below. So R went to R prime under this matrix, this transformation matrix. They want to know, determine the values of P and Q. So what we do is one of the methods to find out our the image of a transformation the image of a point after its transformation, we say the 2 by 2 transformation. So this is your transformation matrix multiplied by your object is equal to your image. So our 2 by 2 transformation is 0p q0. What is our object point?
2, -5.
2, -5 equals to our image point, which is
5, 2.
5, 2. So therefore, what do we do to simplify this? What can we do to simplify here?
You can multiply the transformation by the object and then equal it to the image.
So yeah, very good. We could multiply out the left-hand side using matrix multiplication. So that's going to give me 0, -5p. So 0 add -5p and 2q add 0 is equal to 5, 2. Everybody is okay with this from multiplying it out, right? This by this is 0 plus this by this. This by this is 2q plus this by this, which is 0. And now that we can equate them because they are equal matrices. So -5p is equal to 5, therefore p is equal to -1. 2q is equal to 2, q is equal to +1. So therefore our matrix M is equal to 0, -1, 1, 0. And actually, there are different types of matrix that we can identify like this based on what line they are being transformed by. So according to what axis and all these different things, right? So any questions here? This was pretty straightforward once you would have learned the formula, right? So the transformation matrix by the object is equal to the image. We substitute the transformation multiplied by the object is equal to the image. Any questions here? No? Ready to go? We're ready to go down. Hi, people. Y'all could talk to me, you know. Are y'all ready to go?
Yes, miss.
All right. So determine the values of P and Q. Describe fully the transformation M. So, all right, let me hear what you all came up with. What transformation was this? We went from R to R prime. R to R prime.
It's a translation.
Okay. All right. So what you telling me? R is being translated to R prime by
Messy translation vector 0, -1, and 1, 0.
so remember translation vector is a 2 by 1.
Yes, miss. Miss 2.
So So would this be a translation, seeing that we use this, a 2 by 2? We know a translation vector is 2, 3, or however it goes. You move 2 places, X, 3 places, Y, up, down, accordingly. So we know it's not a translation, right? Because they said this 2 by 2 mapped R onto R prime. So what else can we think about? What other ideas?
A reflection.
A reflect who? A reflect what? How are you getting a reflection to look like that? Huh? In what world is a reflection looking like that?
I was just guessing.
So, all right, so we don't want to just guess, we want to think about it critically. So, a reflection, if this is reflecting here, it might be somewhere down here, right? Unless you have a particular reflection line.
Miss,
Right.
is it a rotation?
So it seems to be a rotation. So we already have the 0, -1. We have 0, -1, 1, 0, right? And if we, so remember we didn't go through this, so I don't want to tell you all too many things about it per se, right? But a rotation that gives you 0. Let me mark. So when you have a transformation of 0, -1, 1, 0, you get a rotation, right, about the origin. But tell me, how much degrees is looking like? If we were, you know, to use some thinking from here to here.
Miss 180.
You move from 4th quadrant to 1st quadrant and end up with 180.
Sorry, Miss. 270.
90. We just went from here to here, you know.
Miss, I went the other way around. My bad.
Oh, wow. All right. So from here right to here, we have 90 degrees anti-clockwise, right? Yeah. Or we could say 270 degrees clockwise. But look, we see that the points are literally, they are connecting the points to the origin. So they are telling you that the origin is your center of your rotation, right? And we see that this is 90 degrees when we measure it. Yeah. So rotation, transformation is something you need to be diving into a lot constantly because it's left, right, and center. Rules. Remember this, remember that, check this, check that, measure this, measure that, right? It's constant. So it's definitely something we will revisit again. All right, so any questions here? So a rotation about the origin 90 degrees anti-clockwise. We also have a way for us to get these 2 by 2 matrices, which I will show you all in a coming question. So we're going down. Everybody's good there? Any questions with this? I know you all would have. So these are 3 lines. Everybody got through to making their 3 lines, measured it, and it was good.
Yeah, miss.
Yeah.
One of them was good.
all.
All right, very good, Aniki. What's the first thing you do? Make a sketch. So my sketch will be QR. I have a 6 centimeters somewhere. So I now have a point P, and I will say about 6 centimeters. And I have a 7.5, a little longer, 7.5 centimeters, etc. Right? So construct a triangle PQR in which QR is that, PQ is this. So the first thing we do is draw a nice long line. We create a point Q. We measure 8.5, create our arc and call it R. We put in our length, right, 8.5 centimeters. We open our compass at 6 centimeters, and we put the metal part here, and we create an arc, and then we open we open it again at 7.5, put it here and create an arc, and they are going to intersect, and then you just create the line meeting at the point of intersection. When you measure it, you should get 6 centimeters and 7.5 centimeters. Everybody understood that and know what I'm talking about and got it?
Yeah, miss.
Yes.
We call that P, right? So you have to show your construction lines, you have to show your measurements, you have to label your lines. All these things are to your mark. So now the second thing you said to do is construct a line PT such that PT is perpendicular to QR. So all we have to do is, you see the same arc you would have done here, creating to make your PT point, all you're going to do is bisect the line. So go back to 6 centimeters, open it to 6 centimeters, and create a big line crossing QR. And then go back to your 7.5 and continue the arc crossing QR. And what's going to happen is you create a line coming down from P, going down and connecting through. Well, of course, it would connect through here, right? And this point will be called T. Everybody understand what I said, right? So instead of stopping your arc pathway, you just continue and you go back. Now we're going to cut the QR lines for both of them. And then at the P point and at the other point of intersection down here, you create a straight line. So you would have now bisected QR from P. And the point here will be T. Any questions?
No, miss.
Any other questions, anyone? All right, measure and state the angle PQR. So just come and measure it. How much y'all got this as when you measured it?
60.
I believe so. Nobody else did it and measured it?
Miss, I got 62 to 3.
You got 60, I think I got 65. Anybody got 65? Anybody got 65?
No
I'm going
worries.
to measure my line. All of y'all got 60?
Yes, I got 60.
What? So my line is so everybody got 60, right?
Yeah, miss.
Yes, miss.
Good job. And measure and state the length of PT. How much is PT? Huh?
5 centimeters.
5 centimeters. You might get 4.9 or something. So if it's very close to that, you know, you just put it and you put an estimate of 5 centimeters. Yeah? All is well, everyone? So, all right, we're going down again. Okay, so Describe in words the geometric transformation J that maps E, F, G, H to E prime, F prime, G prime, H prime. So here to here. What we thinking? What we thinking? What type of transformation? What is J?
Miss J's 02.
J is 02. So, J is mapping here onto here. So let's think. What type of transformation is that?
Miss a translation.
A translation. Nice. Because the points are in the same place, but it just, you can see there was some kind of glide movement, right? So in order for us to check that for translation, we take H and we take H prime. So that will be H plus J is equal to H prime, right? What is H? Three. Add J. J, we don't know what J is. So we put back J is equal to H prime. H prime is 3, -1. So that means J is now equal to 3, -1 minus 3, giving us what?
Miss 02.
0.
Miss 0 -4.
All right, 0, -4, -1, -3. So this is the describe in words the geometric transformation. So now that we got J, J is actually what? J is a translation vector, translation vector, 0, -4. Any questions here?
No, miss.
Anybody got that?
Miss, I had the translation part, but I made a mistake with my calculation.
Anybody actually got it? Nobody? That's very disappointing, y'all. So when you see that we have another revision and transformation paper coming up. Matthew, where you disappearing going?
It's all right,
Why not answering?
It's because, to be honest with you, this first question out of my head, I just didn't do this question.
You didn't do this question?
No.
Why? I think so easy.
Does anybody else get the first question, right?
This one?
Yeah, miss, that's not easy. I don't like it.
For you all to see that is a translation, look, it just moved in the same place.
Miss, I say it was a translation. I just never figured out the vector first.
So if you all forgot how to find translation vectors using
No, Miss,
object
I didn't know
plus
you're supposed to
translation.
find the vector for it too.
All right, fair enough. You could have said J is a translation. Okay, fair enough. But you know, it's always good to be able to solve a translation vector. All right, so what is a translation vector? So we're describing it. In order for us to describe it, we need to know what it is. So what is K? That is mapping this onto this. So first thing, you have to watch the quote unquote object, which is this one now, and the image. What are we observing about the object and the image right now?
Miss, both of them are like, Miss, the sides on opposite places. Yeah, that.
So, correct. So, what we're thinking?
Miss, rotation.
We're thinking rotation because it rotated. H is here, but H is now down here. G is here and G is down here. So we're thinking some kind of rotation. So how many times would I have to rotate this shape to get it to look like this?
2 times.
Twice.
Twice, correct. So I can rotate it clockwise. So that's to the right. And then clockwise again. So that's how much degrees?
180.
180 degrees. So what else can we figure out? So we got rotation, 180 degrees. It could be clockwise or anti-clockwise. You'll still get, because 180, you'll still end up back in that position, anti-clockwise or clockwise. So rotation of 180 degrees. What else do we need to know?
Miss, the center.
And how do we find that?
Let's join all the lines.
Join the lines, the corresponding lines. So E to E prime, H to H prime, G to G prime, F to F prime. Y'all, sorry, it's just horrible. So F to F prime. Where's the center of rotation?
Miss, the center of origin.
The origin, right? Everybody saw that, right? When you connect all of them, it passes through the origin. Yeah, so 0, 0. So we go and we explain that. K is a rotation of 180 degrees, anyone clockwise or anti-clockwise, about the origin, center of origin, or origin, anyone is fine. So, all right, write the matrix which represents the transformation described as above. So what is J? J is a translation. So NT had to come back and solve it, so Lance, I hope you did it here.
This I never did. This I didn't understand what it means.
Huh?
This I never did.
So what you mean, if you know what's a translation, why didn't you go solve the translation now?
It didn't come to mind when reading the question.
It didn't come to mind to write the matrix that represents J.
I almost I didn't understand what the meaning of it.
You didn't understand, right? The matrix that represents J. And you know J was a translation. You didn't know what I was
But I
asking you to
can't
do.
solve something I don't know.
All right, so 0, 4. What about K? What did we say K was? a rotation of 180 degrees. And again, when we go through, we will see that for a rotation of 180 degrees, we end up with K is equal to negative 1, 0, 0, negative 1. Just a hint, what you could do is the format for this. For each angle, a rotation of 90, a rotation of 180, a rotation of 270, right? Anti-clockwise, clockwise. So we have sine the amount of degrees. So let's, how much degrees? We said 180, so we say sine 180, negative, sorry, cos 180. It's going to be cos the amount of degrees. So in this case, it's 180, negative sine 180, sine 180, and cos 180. And when you substitute the angles, which we did, the degrees, we get our answer, which will be a negative 1, 0, 0, negative 1. Where's my paper? Yeah, so K is negative 1, 0, 0, negative 1. A rotation of 180 degrees. Right? If it was anti-clockwise, if it was clockwise, sorry, we do the negative, right? So it's not going to be the 180, 180, 180, 180, would have been negative 180, negative 180, negative 180, negative. That's for the clockwise, right? But we'll get back into that. Any questions? All right, the point P62 is mapped onto P prime, but by the transformation J. So, oh my gosh, if we don't know J, so nobody got this question correct, a whole 50 marks gone. Because one thing led to the next. They came back and they asked the J. So what's the answer now? What's the answer for P prime? We know that the object at the transformation will give us the image. So this is going to be 6,2 at what? 0, negative 4, right? You're with me now though? Are you
Yes,
with
ma'am.
me? Are the rest of you all with me?
Yeah.
Yeah.
Right, so remember to find an image using a translation. We just add the translation vector to the object. So that will give us 0, 2, 6, 2, 6, negative 2. I can't even find my paper to know where we're at. 3. One, 2. Right. Yeah, 6, negative 2 is P prime. What about Q prime? How to find the image of Q prime by K? K is what? This, right? Who remembers how to find the image using the 2 by 2? What do we do?
Miss multiply.
So we put the 2 by 2. So we do K by Q, matrix multiplication. K is negative 1, 0, 0, negative 1 by Q, which is 5, negative 4. What's the answer?
Miss negative 5, positive 4.
Negative 5 and 4, correct. And that's the answer for Q prime. I remember that from when we did it higher up in the paper. I need to put you all in a communication class. We good with this, right? Everybody got through? Drawing your parallelogram.
Yes, miss.
Any questions, anyone?
Yes.
Matthew, did you get through drawing your parallelogram?
Yeah, miss.
Aniki,
Yeah, miss.
Solange, and Leah, you all got through?
Yeah, miss.
Yes, miss.
All right, very good. So, Tanisha, I hope you got through as well. So let us, the figure label P undergoes a transformation. All right, we see, what kind of transformation this is already. Some of them you just see off the bat. What type of transformation is this?
Miss, a translation.
A translation, right? No movement of points, anything like that, same distances. So we're gliding. So it's a translation. What's the translation vector? How to find the translation vector here? Someone.
Miss, I had 6, -5, subtract 4, 2, and I got 2, -7.
So you choose corresponding points.
Yes, miss.
So
Well,
the first corresponding point is 6, 4. And what was the second point you said?
miss, it really
Yes.
wasn't those points. It was the 4, 2.
4, 2.
Yes, miss, and
Uh-huh.
6, -5.
6, 6, -5. So it's going to be your image minus your object, right? So 6
Yes,
minus 5 minus 4, 2. What's the answer for this?
Miss, 2, -7.
2, -7. Any questions here?
Miss, I couldn't just count it.
Yeah, you could have as well. Right, so you could count your movement. So you're going from here and you're saying 1, 2, bam, 1, 2, 3, 4, 5, 6, 7. Yeah, and you're going down, so you know that's -7, and that's a translation T. Any questions?
Now,
So all right, the figure label P undergoes a transformation such that its image is Q. Describe this transformation completely. That's the same. On the answer she provided, draw and label the line y is equal to x. Where's that line? Y is equal to x.
Miss, a diagonal line from left to right.
Correct. All the points will be the same, so a diagonal line. Now they said S is the image of P under reflection, y is equal to x. So under reflection, y is equal to x. How do we get our image?
Miss, XY turns into YX.
XY turns into YX. Very good. I know you will have this as well. Reflection in different lines. So if we have this as 4, 2, what are we going to have? 2, 4. Yeah.
Yes, miss.
And then we're going to have 4, 4. So we end up with 4, 4 again. Then we'll have 7, 2. Now we're gonna have 2, 7. It's kind of weird because 7 is not on the thing. 5, 6, 7. Yeah. And then we end up with 6, 4 and 4, 6. So it's actually going to be like this. No idea how they did it for the whole thing. Any questions there?
No, miss.
Without revision, without practice, without extra work, transformations will mash you up because it's one of the
Miss.
most difficult topics that students comprehend. Yeah.
I was supposed to draw the shape, right? Like I was supposed to answer the numbers in a way. I was supposed to get my own graph paper and draw the shape, right?
Yeah.
Aye.
Well, if you wasn't going to get your own graph paper, you could have put the coordinates for it that would have represented the same thing.
Okay.
Yeah, you got it though?
Yeah, miss.
Nice. So what's the coordinates of E?
4, 2.
What? Describe fully the transformation that maps DEF to its image. That's good. What maps this to this?
A rotation.
Rotation
Rotation of how much?
90 degrees.
Direction.
Anti-clockwise.
Clockwise.
Degree.
Oh,
Center. Center.
Zero, zero.
How you got that?
Never mind.
Huh?
Miss, I connected it. I connected it.
You
I
what?
connected it, then I measured it. I can't remember the two.
Yeah, and then you did what?
I think it's the contractor.
Mm-hmm.
And I measured it from the zero. That's what I did. I measured it from the zero and get 90 degrees as the space in between.
Mm-hmm. So once we connect corresponding points to the origin, because we see that if we connect all the points, they would not give us it will not give us a point of intersection. So in this case, we could have gone connect two lines, bisect the two lines, see where the two lines connected, and it would have been the origin, right? So in this case, let's try the origin. We say, okay, connect here. Most of the times it's actually the origin. They connected 2 points and you connect it back to the origin and you see you get that 90 degrees. Remember, the video was telling us about this as well. And then let's connect F to the origin and here to the origin. When you measure it, you'll get 90 degrees. If we connect E to the origin and here to the origin, you'll get 90 degrees the same way. So about the origin. On the grid above, D double prime, E double prime, F double prime is the reflection of DEF in the x-axis. Where's the x-axis? So where would our D prime be? D double prime? Coordinate. Where would be our D double prime? So it's a reflection of DEF. D, we are doing a reflection of D prime, E prime, F prime in the x-axis. So we're reflecting this. So where would D double prime be? What coordinate?
3.
1, negative 2.
No. We're reflecting this, you know. Where's the x-axis?
Oh, my bad, miss.
This is the x-axis, so this is a mirror line. So where would D prime be?
Miss, negative 2, negative 1.
Negative 2, negative 1. Where's F prime?
Negative.
Negative 4, negative 1.
Negative 4, negative 1. And where's E prime?
Miss, negative 4, negative 2. I mean, negative 2, negative 4.
Negative 2, negative 4. Your reflection. Any questions here?
No, miss.
All right. We already seen what that is as well. Write down the coordinates of ABC. What's the coordinates of ABC? A is,
3, 2.
B is,
6, 2.
C is.
3, 4.
What is A prime?
Negative 1. Oh. It's 2, negative 3.
B prime?
4, negative 3. 2, negative 6. My bad.
C prime?
4, negative 3.
Everybody good?
Yeah.
Right. All right, describe fully the transformation that maps ABC onto A prime, B prime, C prime. What maps this onto this? Quick is the way we know to identify this now. What is it? What type of transformation?
A rotation.
Rotation of
Negative 90 degrees around the center of origin. 0, 0.
So we went clockwise, correct? Around, oh, very good. Once you connect those points there, you see that 90 degrees connected to your origin C. 90 degrees B. 90 degrees. Each of them will give you that measurement of 90 degrees. Around the origin. All right, not bad. Good job, Solange. On the graph 3.16, draw the line x is equal to 1, A double prime, B double prime, C double prime, the image of ABC. Where's x is equal to 1 line? Where's the x is equal to 1 line? Where's the x is equal to 1 line, y'all? Can you hear me? What's this stalling about?
Miss, personally, I'm kind of confused when they say x is equal to what and y is equal to 1. So I'm not sure if this is the answer, but would x be equal to by 1 negative 1?
So if they told you to draw a line x is equal to 1, where is x equal to 1?
Miss, the vertical line cutting through
This
the
is-
x-axis as 1.
So this is x is equal to 1. Yeah? Solange as well?
Yeah, miss, yeah, miss.
So therefore you need to draw a vertical line. If it was y, you draw a horizontal line. Uh-huh.
Yeah, miss.
So x is equal to 1, that's a reflection line. All right, so where would a prime be, a double prime be? Counter blocks, where would a double prime be?
Negative 1, 2.
Where would b double prime be, Matthew?
Negative 14.
Negative 4, 2. Where would c double prime be, Anakin?
Negative 1, 4.
Right? This is a what? Double prime image. Take one geometrical relationship between all three triangles. What is the relationship they have?
Miss, all corresponding sides are equal.
So what's the label for that?
Pardon, miss?
What's the label for that? All corresponding sides are equal.
Miss, a line, one line going through all of them. Short line.
Where you
They
see
are all
line?
congruent.
Thank you, they are congruent.
Miss,
Yeah.
pronounce the word, please.
Congruent.
Thank you, miss.
You're welcome. Right, so they are all congruent triangles. So they have same lines and same angles for corresponding sides, so they are congruent. Nice job, y'all. I think that's the end of that. All right, we're good with this as well.
Yeah,
Yeah.
miss.
Nice. What's the measure of FH?
8.5 centimeters.
I got 8.4.
All right, 8.4, 8.5, average it. Well, I like this one, 8.5. Yeah. Number 5. All right, write down the coordinates of N. What's that?
4, 5.
Everybody good with it? 4, 5?
Yeah.
Yeah. Using the vector notation, describe the transformation that maps element onto PQR. What type of transformation?
A translation.
A translation. So,
Miss, you skip a question.
LMN, did I? Maps onto triangle PQR by a translation vector what? What's the translation vector?
0, negative 6.
0, 0, -6. Again, you could count it from each point, right? It did not move left or right, but it moved down. Each point moved down 6. So 0, -6, or you could subtract the corresponding points, P subtract L. Yeah. What question? Skip out.
Mr. Skipper, question in the question we was doing part 2. No, miss, go back to what we were doing just now, miss.
Oh,
You see now?
part two. Yeah. On the grid above, FGH, on the grid above, draw a triangle FGH, the reflection of element. In the y-axis, where's the y-axis? So this is our mirror line. What's the coordinate of F? So LMN, FGH. So the corresponding lines are like this, right? So where's F? Coordinate of F.
I have -2.
Two.
All right, what is G?
-40.
And what is H?
-4, 5.
All right, nice, simple. F, G, H, and also label your stuff. Like, don't give them any reason to take out marks from you. All right, complete the following statements. Oh, I love fill in the blanks. Who loves fill in the blanks? Yeah, right. So PQR is mapped onto triangle PQR is mapped onto triangle FGH by a combination of two transformations. First, triangle PQR is mapped onto LMN by a PQR is mapped onto LMN by a very good translation parallel to the
Object.
nah. Parallel to the what?
Y-axis.
X-axis.
X-axis. X-axis. So a translation that was parallel to the X-axis. Yeah? Uh-huh.
Yeah.
And then triangle element is mapped onto FGH by a
Reflection.
reflection. No? In the
Y-axis.
y-axis. Correct. Oh, that was so much fun. They should give us more of these things. The y-axis. All as well? Triangle PQR and triangle FGH are congruent. State the reasons why they are. So of course we know why. Why are they congruent?
All angles and sides are equally.
So you're going to put that in two things, right? All corresponding lengths are equal. And then the second one is all corresponding angles are equal. Yeah? All right, let's go. Home stretch. Say the coordinates of the vertex J.
-4, 1.
-4, 1. Any questions?
No.
Say the length of K prime, L prime. The length of this line.
2 centimeters.
2 centimeters. Everybody good, right?
Yeah, miss.
Part 3. Describe fully a single transformation that maps JKL onto triangle. The J prime, K prime, L prime. What do we got there? Crickets. Describe fully
Miss
the single
rotation.
trans. Huh?
Miss a rotation.
If you rotate that, will you end up with that shape? I could rotate it like this. I'll end up with this. I will end up with this.
Necessary flexion.
All right, I'll end up with this, but I wouldn't end up with this.
No, it's not a reflection like that. I don't know how to describe it.
So it's a reflection, but in what line? What
Um,
carries our point from 1, 2, negative 1, 1. Carries our point from 3, 1 to
Miss a
negative
reflection in the
1, 3.
y is
y
equal to
equal
negative.
to x line.
Negative 4, sorry. 1, 4. One, 4, 2, negative 4, 1. What reflection is that?
A reflection of y is equal to negative x.
Y is equal to negative x. So all these things you all lose with the style. Huh?
Wait a minute.
Alright. All these little things that you all lose, was it for style? Was it truly for style? Huh? Matthew. Matthew, I'll call your name.
Yeah, miss.
Did you get that correct?
Miss.
No, miss. So I post there like, what is the mistake? Because the the points wasn't adding up, because you're supposed to get negative y, negative x, right? But I'm like, what is happening? Why isn't it working out like that? So the coordinates here were incorrect. Y'all will help us out. So nobody can say this, these were the correct coordinates. 1, -1, 3, -1, 1, -4. Right, then we see. One second. Right, so 1, -1, 3, -1, 1, -4. Right. And our coordinates with -1, 1, -4, 1, -1, -1, -1, 4. Which way are we looking at? So we're doing a transformation from J, K, L. Everybody's hearing me? That quiet, people.
Yes, ma'am. So hey.
Right, times. So J, K, L onto J prime, K prime, L prime. So what is J? Quickly, what's J?
One -4.
What is the coordinate of J?
-4, 1.
-4, 1. Maps onto what? J prime.
1, 4.
1,
-4.
what is the coordinate of K?
-1, 1.
Maps
1,
onto,
-1.
what's the coordinate of
-1, 3. 3, -1.
y'all forgot how to plot coordinates?
Miss.
No, ma'am.
No, miss.
So how come you wasn't answered? Right, so based on this, what type of reflection is it?
It's a reflection in the y is equal to x line.
Y is equal to X line. Right, and our Y is equal to X line, our point goes from XY to YX. So 1, -4, 1, -1, 3, -1. So it's a reflection, and your Y is equal to X line. State the coordinates of J prime, K prime, L prime, the image of JKL under translation by the vector 5, -3. What's the coordinates of J prime? J double
1,
prime?
-2. That's 1, -2.
Someone else, K double prime?
4 -2.
What's that?
4 -2.
1, -2?
4.
4, -2, all right. L double prime?
4, 0.
4, 0, awesome, right? So remember how to look out our translation. All right, steady coordinates of P and Q. Come on, coordinates of P quickly, please.
2, 2.
2,
2
2,
to 1. I said the wrong thing. 2 to 1.
2 to 1. What's the coordinates of P?
2, 1.
2, 1. What's the coordinates of Q?
4, 3.
4, 3.
4, 3. Describe fully the transformation that maps. What's that transformation?
Miss,
Maps
reflection
here.
in the x-axis.
Reflection in the x-axis. Write down the coordinates of the image P and Q under the translation 3, -6. So
5,
P
-5.
double prime will be,
5, -5.
and someone else, Q double prime will be
7, -3.
7, -3. Awesome. All right, steady coordinates of R and R prime.
Miss 2, 4.
2, 4. R double prime.
0, 2.
Sorry, R prime.
2, 0.
2, 0. I'm up in the Y before the X. Describe completely the transformation that maps RFC to R prime S prime T prime.
Miss, reflection in the y is equal to 2 line.
Very good. If you put Y is equal to 2 here, you will see that is a reflection. Points here, points here, points here. Nice reflection. All right. On your sheet, the image of triangle RST under the enlargement. RST undergoes an enlargement, center 0, 4, scalar factor 3. Draw R double prime, S double prime, T double prime, the image of the triangle RST under the enlargement. So, anyone has the coordinates for R double prime? S double prime and T double prime? Yes, no? Anna Q? Anna Q, was I supposed to hear whatever you said there?
No, I didn't see anything.
Exactly. Do you have the R prime, R double prime coordinates? Aniki, why you delaying? Why you delaying me? Is there another Aniki in the class?
No, miss.
Do you have the coordinates for R double prime?
No.
Thank you very much for responding. Anyone has the coordinates for R double prime? Anyone got through with this question?
Miss 6, 12.
What did we get? 6, 12.
Miss, the scale factor multiplied by the coordinates of R.
So it wouldn't be that simple because of the center of the enlargement. So see, anyone give it an attempt? Anyone else give it an attempt?
No, miss.
Okay, so we need to go through this one in detail. Let me see. We could come back to it. All right, because this will take a little time. Given that the area of RST is 4 square units, calculate the area of R prime, S prime, T prime. Anybody got this?
16 centimeters squared.
So K is 3, right? So K squared by 4. Yes?
Yes, miss.
Given that the area of the triangle RST is 4, calculate the area of the triangle R double prime. We know the scalar factor is 3, so 3 squared by 4. That is how much?
38.
How much?
36.
Thank you. 36 centimeters squared. State two geometrical relationships between R prime and R double prime, S double prime, T double prime. So we know that this is going to be an enlargement, right? So R double prime is going to be running along this line here because this is the center of rotation 0, 4, right? And we know for enlargements, we have to connect R and R prime. So what we would actually have to do, right? What we would actually have to do is, I need to go through all of this right now. Let's finish this. Let's finish this. We'll come back to this. All right. I really want to finish now. So the diagram below shows 3 triangles labeled L, M, and N. L is mapped onto M by a translation. What's the translation vector? What's the translation vector, y'all? Y'all don't want to
M
finish
minus
now?
L.
Huh?
M minus L.
So L is mapped onto M. So M minus L. Yeah, but what is the answer for that? What's the translation vector? Nobody did this?